Good morning. My name is Daniel Beach, and I'm an application developer with OpenSource Connections. We're based out of Virginia. Today I want to share with you about client-side search applications. This is an emerging type of application that allows you to build an interactive front end to a database using minimal server resources. The resulting application is tiny compared to the traditional methods. First, let's look at what we're going to cover in this talk. I'm going to give an overview of what client-side applications are. Then we're going to go into a case study where we recently implemented this approach successfully. And then I'm going to walk through a simple tutorial of how to set up a basic client-side search application using a framework that we recently released called SpyGlass. Lastly, we're going to cover how to avoid a few common pitfalls with client-side applications, and then we'll wrap up with questions. As the world's information continues to grow in size, search applications are becoming increasingly important in keeping up with that data. Search can play an important role in making data manageable. At the same time, organizations are rapidly recognizing the advantage that data discovery and analytics provides. Both of these factors contribute to the demand for better, faster search technologies. One way to deliver great search experiences with a minimum of resources is by building client-side search applications. By definition, a client-side search application is a search experience that is powered by a front-end interface that communicates directly to a database. In contrast, a traditional search application is primarily server-side, with fully rendered pages being delivered from the server. One relies on serving the server resources, the other relies on the resources of the user's machine. Because the client-side search application is primarily utilizing the user's processing resources to handle application rendering, this means that the site can be performant while minimizing costs. So what is a client-side search application? Let's look at how a traditional application is served on the internet. Here, a user visits a website, and the server sends a query to the database, and then takes the response from the database and converts that into HTML that is then rendered and delivered to the final user. That means that each page is being rendered by the server. For big projects, this requires dedicated servers to deliver the site's pages. In many organizations, this also means that you need additional IT personnel and organizational overhead in order to manage those servers. But personal computers and mobile devices are rapidly increasing in power. This opens up a great opportunity. Client-side applications take advantage of this power by harnessing the user's processing resources. In this scenario, a user downloads the initial application along with the HTML, and then this JavaScript application powers all or at least a percentage of the site's interactions. Instead of needing to talk to a dedicated web server, the application can directly query a database like Solr. This means that there is less architecture overhead. Because of the reduced resources, the team of people can be smaller as well. The developers can be more focused on actually ingesting the data, optimizing the database, and building out the user experience. It also shifts the leverage point so that small teams can take on much bigger projects. This opens up a new frontier for businesses with large data sets, especially large organizations. It allows them to inexpensively prototype new applications using large amounts of data. Smaller teams, combined with fewer allocated resources and architecture decisions, mean that you can iterate faster and ultimately ship your product sooner. From the end user's perspective, the experience is faster because they don't have to wait for new pages to download. Once the results have been returned from Solr, they can be immediately displayed in their browser. In general, client-side applications use less resources, submit fewer server requests, and can save developer time and headache. Speed matters. Client-side search applications can be faster to build and, more importantly, provide a faster experience to the end user. Now let's look at a case study from a recent project that we did for the United States Patent and Trademark Office. This is called the Global Patent Search Network. And basically what it is, it's a prototype of a next generation search interface for them where they could have multiple foreign language patent types. The requirements for this project were pretty challenging. The United States Patent and Trademark Office had been given over 4 million patents by the Chinese government. And this included scanned pages, the original Chinese text, along with machine-translated English. Our mission was to store this data, index it, and then make it searchable by the general public, all within a very short deadline and a minimal budget. Our deliverable was to be a deployed proof of concept for this type of application. So we weighed our options and decided that a client-side search application was the best approach for this project. Our technology stack ended up being Apache Solr for the back end. This is where we stored all of our text data, so the original Chinese, the machine translation, as well as paths to our assets that were stored in Amazon S3, which is what held all of our patent images. So we had thumbnails and large original images that we created, as well as just a couple HTML and JavaScript files to deliver to the browser. And all those were linked from our Solr instance. And the actual front-end application is powered by an Ember.js app. We decided to go with Ember.js because it provides a good baseline for some of the architecture defaults when you're developing your application. And it allowed us to focus on building out application functionality instead of rewriting things like how to bind data to a template and also how to handle JavaScript templates. So in general, it provided a stable base for our application development. So how did the project turn out? Here we have the homepage of the GPSN. And this is all powered by Ember.js. We're loading multiple dynamic elements in so that the header is a separate file, and the entire page is controlled by Ember.js, and specifically there's a concept of routes, which, because this is a single page application, routes handle what content is placed in which outlets. So as you're navigating around the site, it looks like you're going in between pages. One thing to note is that the browser history is completely maintained, so when you go back and forth throughout the application, the app remembers state. So let's go ahead and make a query for microchip. Here we have the results page, and this is a pretty standard list view. We have a patent title on the left. You can click it for a summary of the patent, and with the ID and publish date on the right, and an option to select an item for print. Here we have the expanded result, and you can see an overview of the patent along with highlighted snippets and matches for each field, as well as a quick thumbnail view so that you can flip maybe backwards to where the figures are, and an examiner could figure out if this was exactly the patent that they were looking for before they click through. Here are some other search components that we have on the site, and note that this is a fully featured application. We're not skimping on functionality just because it's a client-side application. We have facets, including multiple groups, including kind code and publication year. And all of these are automatically bound to a concept of a searcher that we'll get to in a little bit. And the last screenshot from this is the actual patent detail page. This is the primary patent reference. You can toggle either the Chinese or the English or both. You can see here that the highlighting parameters were passed in from our initial search, so we're highlighting microchip throughout the document. And we have an image viewer underneath that second image. It allows you to navigate the full patent images, which is the official version of the patent. And as you navigate through those images, the application is loading an image in whichever direction you're navigating. So either if you're going forward, it'd be ahead of you, or behind if you're going backwards through those images, which allows us to conserve resources and enable the viewing experience to be fast and performant. So what were the results? For the majority of our searches, and remember this is over 4 million patents, and they can be 200, 300 pages long. The majority of our searches are well under 2 seconds, and our 95% load time is under 5 seconds, with a general deviation of less than a second and a half. In general, it's very lightweight. It feels fast. It's fast loading. So how would you get started building a client-side application? One way to do that is a framework called SpyGlass that we recently open sourced that gives you a jumping off point to building a simple search interface with Solr and Ember.js. So first, let's look at an overview of some of the components or concepts that SpyGlass contains. The first one is the idea of a searcher. And basically, this is a class that sets up some defaults for how to handle Solr parameters, as well as what to do once the results are returned. So basically, this is a wrapper around an AJAX call to Solr to get those results. And we're keeping track of state of things like the query and the FQ, etc. Next, we have a search input, and this is tied back to the searcher, so that when you input a query term, that's then tied to your queue parameter. And we also have the idea of a result set, and a result set is an observer that basically gets notified every time that the searcher gets new results. So if you executed a query, the searcher would get the results from Solr, and then those would immediately be pushed out to the result set that's watching it. There's also the concept of facet groups, which are basically a container for the facets returned by Solr, and then the individual facet, as well as the state of that facet, whether or not it's selected, so that we can accurately maintain what should be in the FQ parameter. And the last thing is infinite scroll, so that when you get results, you can just scroll down the page and not have to worry about pagination. So how would you set up a simple project? The first thing that we're going to do is we're going to set up a searcher class. And this extends the SpyGlass namespace, which just keeps all of our functions separate from the other Ember application functions or from your general Ember application. And then we're extending a Solr searcher class, which is our base searcher for Solr that keeps all the conventions of how, for instance, Solr facets are formatted and how we need to reformat those in order to actually make them more usable and easier to work with to print them out to the screen. And one thing to note about all this code is that it's included in the initial download, and when you would actually be doing this, you would just be modifying a few values that are in yellow. So the first thing that we need to do is we need to actually point it to our Solr. So here we would have our Solr URL and our actual collection and handler at the end there. And then we need to in our parameters, define the actual fields that we want to return to this searcher. And here we're just returning three sort of baseline fields of a title, a description, and a link, which are sort of the minimal fields that we need to return for the actual search page to work. And then we have a few default parameters that we don't need to change, and there's a rows parameter that would allow you to change how many actual results are returned. And that's pretty much all of the parameters for the Solr searcher. Again, you only need to actually change the yellow values. You don't actually have to write this or necessarily know why it works, but this is just we're actually initializing the Solr searcher class here for our specific Solr instance. The next thing that we need to do is actually add those custom fields that we're returning from our individual Solr to the HTML template. And the HTML template is written in something called handlebars, which is a JavaScript templating language that is built in conjunction with Ember.js. And it gives us some nice functions here. So here we're looping through. This is tied directly to the result set. So anytime the result set is updated, we're going to output each one of those results into this list. So here we have a list item, and we have two fields here. We have a link and a title, and those fields are whatever the actual field names would be from your Solr instance. So title could be title_en or whatever your actual Solr field is. And then finally we have a description here, and there's three brackets around that one because that allows us to actually output or basically not escape any HTML that may be in the description, but that's a choice dependent on your actual situation. So here we have a basic results page, and we can get results based on our configuration. So let's add some facets to that. Back to our searcher, just need to uncomment a few facet parameters, such as the facet field and facet.limit, and fill in the actual field names that you're going to facet on. So that could be price or type or any other kind of field that you would have in your data set. And then next we're going to create an instance of an actual facet group, and this is also included in the app.js. So here we're creating facet group 1, which is, you could call that whatever you wanted. We're creating an instance of a facet group, and we're assigning it to the searcher that we created just a few minutes ago, and we're assigning it a field name of whatever our actual facet field would be. So here it's abstract_en, and we're going to give it a display name to show on top of the fields. And finally we need to add that to our template, and we would do that by adding a view, and here that would be app.facetgroup1, which is what we just initialized. So here we have a completed minimal search engine based on SpyGlass. A few nice benefits of the handlebars templates are the ability to add blank states. So here we have a few state things. We have messages for is searching, no results, or all results loaded, and just some messages based on the state of the application there. You can go ahead and download it, try it out. I would definitely love feedback. We're going to be merging in some new improvements soon from other client projects that we've been working on, such as autocomplete, pagination, and adding an Elasticsearch adapter or an Elasticsearch searcher. So what are some common pitfalls with building client-side applications? I know some of you had questions about security from the beginning of the talk. So what can we do to make things more secure? The first thing would be to make sure that you lock down your Solr configuration. Specifically, making sure that you don't allow any custom Qt parameters, making sure that all of your update handlers are removed from your configuration. Additionally, you can put Solr behind a reverse proxy and using a regex expression to lock down exactly what queries people could actually use to search for. In GPSN, we rolled this into the load balancer. You could have a whitelist on a server that could just forward the requests through to Solr. That way, you put one level of another block in between Solr and your actual client-side application. And another thing this approach is definitely easier to do if you don't have to update as frequently. If you're only updating in frequent intervals, you could swap out a completely different instance in order to not ever open up the update handlers. Another aspect would be if you had internal content or a subscription model, then you would need to put your entire application either behind a network firewall or an authentication server for your actual application. What about Google? For a lot of search engines, you don't actually need the results pages to be indexed, but that does mean that you need to have actual static pages for any of your real content. Or there are special ways to get Google to recognize your AJAX content, and they have a whole section in their webmasters documents about AJAX crawling. And because this is a single-page application, there aren't traditional full reloads. You're not navigating to new pages, so on any route transitions inside the application, you'll need to send custom pushes to Google Analytics if you want those to work correctly. Be reasonable about the number of Solr requests that your application generates. This is especially true if you're doing autocomplete. You can get into trouble if you're not careful. For instance, if you are returning a list of suggestions and the user is still typing in a valid suggestion, don't search for suggestions again, and don't execute a query until a user is 2 to 3 characters into a word, depending on your actual engine and how many users you have. The smaller the actual files are, the better in general. Make sure that all your JavaScript and CSS, etc., are minified. With handlebars, you have the ability to pre-compile templates, if at all possible, and then you can just use a much smaller handlebars runtime build in order to render those. Your users will thank you for any size benefits that you can make. Above all, use common sense. Realize that client-side search applications aren't the right fit for every project, but it's definitely something that I would recommend trying, and I think that you'll find that you can get great results and better enjoyment from your projects. Thank you. Do you have any questions? Do I need to go back to the security slide? Thank you very much. I guess we can break early for lunch.